warm welcome to everyone joining. Thank you for being here. Go ahead and get yourself ready. Grab a notebook, a pencil, or pen. Whatever you choose to write with is fine. This is math from the void. Math coming at you pretty much out of nowhere. And today, we have a calculus prep problem. This problem is intended to have you represent a word problem situation. And you're going to be moving around some variables without values given. So this is kind of an infamous no number problem, as they're sometimes called. Go ahead and give the problem a read and give yourself about maybe 6 or 7 minutes. You don't have to do both of these parts in 6 or 7 minutes. Mostly see if you can write the total area in terms of L and P. And as a bonus, if you'd like to express the area as a quadratic in L and express the quadratic in P for the area, I encourage you to do that. It should probably take about 3 or 4 minutes for the first one. And if you try the other one, it should only take about 30 seconds after. You'll see why. In any event, give yourself some time to do it. You can pause the video. And then when you're ready, unpause the video, come back, see how we did it here. First things first, we need a diagram for this rectangle. So I'm going to draw the rectangle as such. We have the length, and we have the width, and the equilateral triangle is attached to the width. So something like that, where this is also length W, and this is also length W, because equilateral triangles have all sides equal length. Okay, now the total perimeter is listed as P, but let's go around the entire shape and figure out what the perimeter is. So if L is up top, L is also down here, which means this is L plus W plus L plus W plus another W. So here we can say that the perimeter is equal to 2L plus 3W. Great. Now what we want to write is we want to write the total area of the figure, which means we need the area of the rectangle plus we need the area of this equilateral triangle. So let's write that out. The area is going to be, or rather the total area is going to be the area of the rectangle plus the area of the triangle, right? So let's think about those things separately. Rectangle area is pretty easy. That's a blast from the past in geometry. So that's simply going to be L times W plus the area of this triangle. That's the area of an equilateral triangle. If you don't already know, you can calculate this by using 30, 60, 90 triangles, but the area of an equilateral triangle with side length S is given by square root of 3 over 4 S squared. So in this case, we're going to have square root of 3 over 4 W squared, because we're using W for the side length. Great. Now, we want this to be expressed only in terms of the length and the perimeter P. So we're going to have to replace the W. We want to get rid of this W. We want to replace it with something. So here we can take advantage of this perimeter equation. We can solve for the W and get W by itself. We're going to have P minus 2L equals 3W, which means P minus 2L over 3 equals W. I might even prefer to write that as 1/3 times P minus 2. Now that we have an expression, minus 2L, sorry. Now that we have an expression for W, we can go ahead and replace W in our area equation, and we'll put it in right there. So we have L times 1/3 P minus 2L plus root 3 over 4. Here's going to be the doozy. 1/3 times P minus 2L. That's being squared. Yeah, so let's take some care into that, why don't we? Let's multiply L and 1/3 in there, so we're going to get 1/3, and technically we're done, by the way. Like, this is, technically the expression in terms of L and P. It doesn't look all that great, so let's get kind of a clearer picture. We're probably going to have some common terms that we can cancel. And so we're distributing 1/3, and we're also distributing L. So this is going to give us 2/3 L squared. Lots of L stuff and P stuff. That's the purpose of rewriting this entire area expression. We're writing it in terms of length and the perimeter. Plus, let's work out this squared part here. This is going to be 1/3 squared times P minus 2L squared. That's not so bad. We have 1/9 P squared minus 4PL. You should be very smooth with this kind of multiplication if you're at this stage in the game. If you're in calculus, you need to be able to expand binomials quickly, like reasonably quickly. And we're multiplying all of this times rad 3 over 4. So we're going to end up with rad 3 over 4 times 9. That's 36. And then we have P squared minus 4PL plus 4L squared. Got it. See how we have some common terms here? We have PLs, and we also have some L squared terms to combine there. Yeah, quite interesting. So let's get everything together if possible. If I can distribute this coefficient of root 3 over 36, that would be kind of nice. So I'm going to end up with root 3 over 36 P squared. That one's nice and easy. But on the next term, this is going to cancel a little bit with the 4. So I'm going to have root 3 over 9 PL. And again, we're going to get a little bit of cancellation with 4L squared. So that's going to give me plus root 3 over 9 L squared. Okay, and how can I combine that? Well, I can combine that with this L squared term. That's going to be minus 2/3 L squared. And then I can combine the PL terms together. So plus 1/3 PL. And it looks like I need to change the denominators here in order to combine them. So I'm going to call this 3 over 9, giving me 3 minus rad 3 over 9 in front of the PL. And I'm going to turn this into 6 over 9 so that I'm going to have root 3 minus 6 over 9 times L squared. The P squared term didn't really have anyone else to interact with. And this is our total area expression. Now the reason why I've put it in this way is because we're going to look at the quadratic nature of this equation. Now you can think of it in one hand in terms of a quadratic on L, or you can think of it on another hand as a quadratic in terms of P. Let's think of it first as, what was part A? Express the area as a quadratic in L. So what we're going to do is we're going to treat L just like we would normally treat X. So L squared is kind of like X squared. Therefore, the leading coefficient is going to be this root 3 minus 6 over 9. That's my coefficient on L squared. That's kind of like my A value. Then I'm going to have 3 minus rad 3 over 9 times P times L. All of this, including the P, is like my B term. And then lastly, the constant term, which does not depend on L at all, is this rad 3 over 36 P squared, because P is just a number as far as L is concerned. It's a different variable. That is our total area expressed as a quadratic in terms of L. And if we wanted to use the quadratic formula, we can do things like that. wouldn't really help us out too much here. We could use the quadratic structure to determine a maximum, since we know that quadratics either have this kind of a shape or this kind of a shape. I wonder if you can tell from this equation which shape it's going to have. Well, think about this situation. This situation needs to have a maximum area, so it would have to be the shape which has a maximum on it. But let's confirm, because that means that this would have a negative a value. And if you look at the a value, it is negative, right? Because square root of 3 is pretty small. It's a little less than 2. And if we subtract 6, that's definitely going to give us a negative. Dividing by 9 doesn't change that. It's still going to be a negative. So this is definitely less than 0. Okay, and if we want to think about this for part B's sake in terms of P as a quadratic in P, then we would just go back to looking at it in this other format here. If I just do a little bit of rearranging here and put this as the coefficient on P, that would be my B value. And then this will be my C value, right? So either way, we could express this as a quadratic in P or a quadratic in L. But to see the quadratic come out of this constraint is really quite a fascinating quality. So we haven't done any calculus with this yet, but I want to prepare you for representing a situation like this, because you will learn how to do calculus processes with this type of equation. For example, finding exactly what length would produce this maximum area, or finding the perimeter that would produce a maximal area. Those kinds of things are secrets that are left for your future journey in math. Okay, I think that's enough blab out of me. I'll see you guys next time.